Prime time. Part of prime time, you're going to have a portfolio to do. And I'm explaining the portfolio here. So you're going to have a page you download that looks kind of like this. There's one more box there that I include, but it's self-explanatory what that last box is. It's just where you found your number. But what you're going to do is you're going to find numbers. So let's say I find my first number, looking around my house, 2080. That's where I found that. That's the last four numbers of my zip code. So is that prime or composite? Well, it's not a prime number because it's even, so that makes it composite. The factors. So you do the divisibility test that we talked about in our last video. So 1 and 2080 are our first factors. Clean that up. It's even, so 2 goes into it. And half of that would be 1040. 2 plus 8 is 10, so 3 doesn't go into it. 1040 is even, so 4 will go into it. And then half of 1040 would be 520. 5 will go into it, because it ends in a 0. So 5 goes into 24 times. 5 goes into 8 once, with 3 left over, and 5 goes into 36 times. So it would be 416. It's not divisible by 6 because it's not divisible by 3. It's not divisible by 7. 8 it would be divisible by because 520 is still even, which is our 4. So half of 520 would be 260. It's divisible by 10 because it ends in a 0. So that would be 208. And I think there's a couple more in there, but that's good enough. I got enough factors. That number wasn't the best number to find factors because that one has a ton of factors. But most of you are, I mean, if you give me that many factors, I'll say it's good enough. And then the last thing is prime factorization. So you take that 2080, and I'm going to show you how to do prime factorization, and then we'll write it in the box. So there's two different methods. There's the tree method, and then there's the what I call upside down division. So I'm going to do the upside down division because that's the method I prefer, and then I'll show you the other one. So start with 2. So 2 goes into 2080, 1040, and I already did some of this. 2 goes into it, 520, 2 goes into it, 260, 2 goes into it, 130, 2 goes into it, 65. No, I'm out of 2's because 2 won't go into 65, and next I go, 5 will go into 65, 3 won't, so 5 will. 5 goes into 65, what is that, 13 times. And 13 is prime. So now I got my prime factorization. I got 1, 2, 3, 4, 5 2's. So that's 2 to the 5th power times 5 times 13. So I can go back up and write that in. 2 to the 5th times 5 times 13. So if you don't like that method, let me show you the other one for prime factorization. Get some room here. So we take 2080 and do a factor tree. So a number that will go into it, try and think big. Looks like 20 will go into it. So 20 goes into 20 once, 20 goes into 8 0 times, 20 goes into 80 4 times. So 20 can be 4 times 5, and 104 would be 2 times 52. 4 can be broken down into 2 times 2, And every time you get a prime number, circle it. That helps you remember where all your prime numbers are. And then 52 can be broken down to 2 times 26. And 26 can be broken down into 2 times 13. So if you count, I got 1, 2, 3, 4, 5 2's. So that's 2 to the 5th, 1 5, and 1 13. So I get the same answer, 2 to the 5th times 5 times 13.